Hi guys, I hope you are okay. Me too, I'm fine. So today guys, we are going to look at the volume of solids. So the first thing we do is we read the question and then we can answer it. Find the depth of a cylindrical tank if its capacity is 1848 meters cubed and diameter of the base is 14. So here we have a tank. And we are saying that the H is supposed to be like the depth. So actually this tank should look something like this, guys. It should look something like that. That is our tank. So we have the H there, or the depth. Also we have this circle, which can be represented by the area is pi r squared, like that. Now guys, we are given the capacity. So what we need to get is, first of all, the volume of the tank. The volume of the tank, we know it is given by pi r squared h, of which pi is known. R squared we get from this. The base is 14. That is 14 divided by 2. So r squared is going to be 2. And so guys, h is what we are looking for. So we come and now replace this equation. We have pi, which is here. We have r, which is now 7 squared. Then we are left with the h. This one gives us 1848 meter cubed. So this one is meter cubed. So when now we look for the h, we are going now to put our values. These values, we will bring them here. We are left with only h. So for that, we have here 22 all over 7. One of the 7 will cancel. These are 2 7s. So we'll be left with 22 times 7. And this is what we have put here. And finally, guys, we get, when we divide that, we'll get 12 meters. So that is the height or the depth of our tank. Coming to the next question. Question states, what is the ratio of the volume of a cone, a sphere and a cylinder if each has the same radius and height? So here we have the radius of the sphere, cylinder and cone. Say that they are all equal. Even the height of the sphere, cone and the cylinder, they are all equal. So now we say that r is equals to h. So wherever there is a h, we can put r. So because h and r are equal, so volume of the cone will be given by that. This one you can replace it with r. So finally we shall get a third pi r cubed, because this is the volume of the cone. And the volume of the sphere is 4 over 3 pi r cubed. So this one will remain like that. This one does not have a height, but the diameter is equal. Then coming to this other question, this other volume of the cylinder, we know, as we have done there before, in the first question, we have pi r squared h, but we have said h is equals to r, so we will get pi r cubed. This one now will be r. So the volume ratio for the cone, we have the cone as a third pi r cubed, the sphere like that, 4 over 3 pi r cubed, and the cylinder pi r cubed. So when we now come and cancel, we can cancel the pi's like that. The r's are all the same. We can cancel, so we are left with something like this. For us to have eliminate the fraction, we can multiply here by 3, here by 3, and here by 3. So finally we get this as our proportion or our ratio. Then we have this question here, guys. It says, if the curved surface area of a right circular cone is 110 centimeter cubed and its radius is 35 centimeter, find the volume of the cone. First of all, we have the area of the curved surface. The area of the curved surface is given by that. That is the area of curved surface. And we can actually because here we are given the radius. Here we have the radius, so what we are left with is L, and that's what we are looking for. So what is important, guys, is to know the area of curved surface area, and which is this. So guys, when we draw that cone, of course this cone is supposed to be something like this, guys. Now we have divided it into, is actually supposed to be like that. So this is L, this is also L, and then we have the H here, something like that. So this is the arrow we are looking for. Here we have given the radius and we have the height. So we can now be able to get the L, because having the height, and we have actually we have the L, which is 91, and we have the radius, which is 35. We are saying if the curved surface area of the right circular cone is that and its radius is 36, find the volume of the cone. So using this first equation, guys, that is the surface area. Using this one, we are able to get the L. So guys, L, we can get it, and after we did that, the L actually was L is actually 91 centimeter. When we do this, we get L as 91, and that's why, guys, now when we now come here, we are now looking for the H, because L we know 91, R we know is 35, then we can find H using the Pythagoras theorem. So our H now is going to be given by that, because as you know, Pythagoras theorem is R squared plus H squared is equals to L squared. So that is R squared plus H squared is equals to L squared. But what we do not know is actually H squared or H. So we shall have now, we can now bring this R this side, so that we have L squared minus R squared. This is equals now to H squared. Now you can replace L squared to be 91 squared minus R squared is 35 squared. So our H now we can be able to get by what I have done here now, guys. And our H is now 84. Now we are looking for the volume. The volume of the cone is a third pi R squared H. Now we've been able to get the H. We did not need the L. And so this is the H. So when we multiply now, guys, this is what now we get as our volume in centimeter cubed. Going up to number 4, or the next question, we have find the water weight in conical vessel that is 21 centimeter deep and 16 centimeter in diameter. This is our cone, and now we have the diameter 16 and the height we have 21. We are looking for the weight, and guys, we know that the weight is volume multiplied by the density. So we can first of all look for the volume. The volume is given by this. We have pi, we have R, 16 divided by 2, and we have the H, which is 21. So we get the volume here. After we get the volume, now we can multiply by the density. This is the volume in meters cubed, and this is the density in kilogram per meter cubed. When you multiply, now you can be able now to get your weight, and that is the weight in kilograms. Finally, guys, we have this. The question reads, how many bricks, each measuring that, be needed to build a wall of that? Volume of the wall, that is the volume of the wall, or where the bricks are going to fit. Volume of a brick, this is the one brick, because The volume is length times breadth times thickness. We get that. The same case with the wall. So when we divide that and that, we are going to be able to get the number of bricks now. And the bricks are 6,400 bricks. So guys, thank you for listening to me. Bye bye.